What's up everybody, my name is Andrew and welcome to my YouTube channel. Today we're going to be talking about electric longboards. Not only how to build one, but maybe how to do it on a little bit of a smaller budget. So the first thing we got to do is talk about what kind of components we're going to need for this. I'm using a brushed DC motor, basically because that's what I have. This motor came from, or it was designed to be used in a Razor electric scooter like for kids. This is the only reason I'm using a brush motor. I realize that brushless is the next and greatest thing, but brush DC motor because that's what I had laying around. The next thing you're going to need is something to drive the motor. Since we are using an Arduino, that's definitely not going to be able to switch the power that we're going to require. So get yourself a DC motor controller. I'll have links to all the stuff that I used in the description below. We're going to need receiver and transmitter so that the rider can give input to the motor. That communication is going to be handled through the Arduino to the motor controller. So the transmitter gets hooked to the Arduino. Arduino sends a signal to the motor controller. The next thing we're going to need is a step-down voltage converter so that we can get 5 volts to the Arduino off of the power supply that we're going to use for the motor. Other than that, you're going to need a lot of stuff to mount up the motor and all that kind of stuff. I bought a waterproof case. Motor mount and belt and pulleys all came from eBay. Obviously, you're going to need a skateboard as well. So what we need to do is we need to design and 3D print this washer here. So talk about how I designed it, a little bit of design for manufacturing, or in this case design for 3D printing. So essentially what I needed was, when I bought this kit on Fleabay, it was this gear, this drive gear. There's 5 holes threaded in the back of this that accepts an M4.5. It's weird. This was like the longest size I can get in an M4.5. I needed to actually get longer screws because I made this washer. But anyways, I want to give these cap screws something to bite on to carry this clamp load that I'm going to put on. 5 cap screws holding this gear on the back of the wheel. So I want to spread the load between the cap screws. So that's what I did. I designed a fairly thick 3D printed part. The layers are going this way in the 3D print, so it's going to keep everything in compression. So when I tighten this up and put the clamp load on, everything should stay together. It's going to carry the clamp load. It's then going to span these gaps, or well, for the most part it will. It is only 3D printed PLA plastic after all. So yeah, I needed to design it to make sure that my 1/2-inch socket fits in there. So I had a constraint on the ID, I had a constraint on the OD. Also, I needed to kind of match the angle on the inside of this wheel. So we'll talk about how I incorporated all these things into the design. I also needed to go ahead and make this. So once I had this made, making this was easy. I just fill in the center here and add my alignment pin. So what I needed to do was basically align these 5 holes through the center of the wheel. The center of that bearing is always going to be the center of this wheel. So that's a pretty easy alignment feature there. So this alignment pin is in the center of the part. My holes again are spaced the same. So essentially I just throw this guy in the center of the bearing there, and then I was able to drill right through all 5 of those holes, and it gives me a very accurate way to drill 5 holes. Because essentially I have a CNC machine here that's going to tell me where to put the holes within a reasonable level of accuracy. I don't own a metal lathe, so we got it checked up here in the wood lathe. All we really need to do is take some material off here. You know, even if we take this coating off, it may just do it. Not going to be using any tools. I'm not going to attempt to use the carbide wood tool on this. We'll just use the old file and sandpaper trick until we get her where she needs to be. Again, going back to using what you got around you. Don't have a metal lathe, don't plan to buy a metal lathe. I'm not going to go buy a metal lathe just for this project. So here's what we got. Take a look. Alright, so it's a new day for me. It's a beautiful Saturday morning. Got the sprinklers going on outside. Got my coffee. Now that the hardware mods are done, we're going to go ahead and jump right into the electronics. This is going to be pretty high level. Check the description for the full details. And if you have any questions, let me know in the comments and I'll try and help you out. are all together. Nothing left to do but go take her for a spin. We'll have to do that tomorrow because it's all dark outside, but we'll give you a little sneak peek right now.